Welcome to day 4 of Console AI Chat Client in Rust Programming Language and Ratatouille. It's a Friday in my time zone. Good morning, good afternoon, good evening. Today I'm just excited to continue working on the pop-up dialogue. I wanted to add a little bit of animation in the button click event. I think last time I was trying to add a delay, but it didn't seem to work. So I'd like to fix that today. So the code is still not that organized yet, but once we establish the intended behavior, I think that will be the time we can refactor the code or tidy things up a bit. So join me once again live in one take, no shortcuts and no secrets. So let's just start programming. All right, welcome back. So last time I think I added a delay. Yeah, this one. So what I wanted to do was to show this if the yes button was pressed and then switch it to this one. And in between I wanted to do a delay. However, I don't think that seemed to work. So I commented it out. And then maybe we can check the document again, because this time I was trying to mention that it's how it works is the immediate mode. Searching for it in the documentation. Concepts, is it under concepts? Rendering widget traits. Widget, stateful widget. Or was it in the Hello Ratatouille? Okay, so that's the code running the app. Counter app. Paragraph. Application state. Okay, so I think it's here. Okay, not that one. JSON editor. Main screen. Where was that again? Examples, apps, app examples. Layout. rendering. Here. Oh, so it's here all along. Rendering. Okay, what is immediate mode rendering? Immediate mode rendering is a UI paradigm where the UI is recreated every frame instead of creating a fixed set of UI widgets and updating their state. You draw your UI from scratch in every frame based on the current application state. In a nutshell, retained mode. Oh, so these are the two different types. If it's retained mode, you set up your UI once, create widgets, and later modify their properties or handle their events. In immediate mode, you redraw your UI every frame based on your application state. There's no permanent widget object in memory. So it's redrawn all the time. Okay, advantages. Simplicity without persistent widget state. Your UI logic becomes a direct reflection of your application state. You don't have to sync them or worry about just widget states. Flexibility. You can change your UI layout or logic anytime, as nothing is set in stone. Want to hide a widget conditionally, just don't draw it. Yeah, so just don't draw it. Some conditions. Disadvantages. Render loop management. Yeah, so this one we have a loop. So the one that is calling draw is a loop here. In immediate mode rendering, the onus of triggering rendering lies on the programmer. Every visual update necessitates a call to draw. Hence, the rendering thread is inadvertently blocked. The UI will not update until thread resumes. The Ratatui library in particular only handles how widgets are rendered to a backend. Backend would in turn use an external crate cross term to actually draw to the terminal. Event loop orchestration. Along with managing the render loop, developers are also responsible for handling the event loop. This involves deciding on a third-party library for the job. It's popular crate to handle key inputs, and you'll find plenty of examples in the repository and online for how to use it. Storm also supports async event stream if you're interested using Tokyo. Okay. So we need to handle it ourselves. Draw. And then when I place the thank you for subscribing. When I place the delay, the thread sleep, the delay, I think it was pausing for 5 seconds. I think this is not the best place to place here. Or I'm wondering, maybe we can use some reference. So Control Q, tab, then if I press enter, enter is pressed. Tab yes, true, no, false, enter pressed. So here, yes button pressed. So once it goes in, What can we use as reference? Maybe there's some examples. Recipes. Showcase. Showcase apps. Okay, this one doesn't have, yeah, it doesn't look like an animation. Beat cider. Maybe this, but it looks complex. CSV lens. To Git UI. Material, Minesweep, oatmeal, oh, this one, some animation, Oha, rain frog, task warrior. Templates. Where are the other examples? Widget examples. Okay. This one has some sort of animation also. Calendar, canvas, chart. Scroll bar, sparkline, table. Oh, tabs. Tabs looks nice. Okay, so for bar chart, okay, there's a loop. It's not a loop. There's the loop. Well, draw. Okay, so draw is here. Render widget bar chart bold. Vertical bar chart. Vertical bar chart. Map. Vertical R. That's all. Temperatures. Okay, temperature is here. So when it's rendering vertical bar chart, it's getting the values from temperatures. So 0 to 24, 50 to 90, 50 to 90. Okay, but this is a new app. Run. How does it know when to render what? Okay, we have a vertical bar chart. Then you have the temperature here. Yeah, there's no delay. It looks like this. Where's this coming from? So there are three. Bar chart. Where's bar chart? Okay, so there are three. 1, 2, and 3. Then we are rendering 1, 2, and 3. Vertical bar chart, horizontal bar chart. And then you have this one. Into centered line. This code doesn't seem to look like this one. That is strange. Data 1, data 1, data 1. I think it's different. It is different. Let's look for another examples. Entering. Okay, so all we have is the showcase. Apps built with Ratatui. Maybe let's open this one. Oh, it's the same. The progress bar, I think. Which one can we use? Preferences. Okay. Development tools. Maybe this one. Product, games and entertainment. Let's see. Games and entertainment. Battleship. Game of life. Minesweep. Tic-tac-toe. Game of life. Game of life. Let's check the source code. Main. Okay, let's start with main. Okay, so time duration is also here. Maybe we can get some hint here. Duration, tick rate. So the loop is here, draw. Chunks, we have canvas, and the widget canvas chunks. Event tick app update. App update. Game. Okay, so game. What does it do here? Didn't mention anything about time here. Maybe under events. Time duration. Okay, so here. Events. Thread spawn. Thread slip tick rate. Send event. Config. What is this config? Config tick rate. Duration to 50 millisecond. Okay, so if we come back here, app update. CTX canvas paint. So the loop will just keep on painting, and whatever it is that is being painted is an update. What? For another example. Second media. I remember there was that Ratatouille ASCII art somewhere. I think that one. Yeah, this one. Ratatouille tutorial. Hello, Ratatouille. Maybe this one. Main.rs. And this is not the one. Where is this? Ah, demo 2. Demo 2. Okay. Demo 2. Oh, it's inside Ratatouille itself. Examples, apps, demo 2. Do we get this one? Maybe from Ratatouille. Then examples. Okay, let's do this. So here I'm going to check out the code. Stop this for a while. Series 3. Okay. Git clone. Git clone. So we're cloning the repository. Then let's get to examples. Then I'll open up Visual Studio Code. Demo 2. Okay. Main.rs. Readme. Cargo run p demo 2. Okay. Let's copy this and then let's see. Run p demo 2. There. So what do we need to do? Press left, right, oh, left, right. This try is D. Then where's the animation? Again. D. There. Okay, so let's use that as reference. Let's start from main. Main, what does it do? App run is here. Let's go inside run. Run is inside app. Then here you have the loop, and you have the draw over here. So let's take a look at draw. Draw. Try draw. Render callback. Frame. So this is callback frame. Render. Clear the terminal and force a full redraw next redraws. Call. Let's go back here. Run. About. Maybe it's under about. About tab. It's the about tab. I think this is the about tab. You press D. Okay, we get something like this. Okay, so that's the recipe. I need to find this D. Okay, so this Ratatouille is a Rust crate that provides widgets. That is here. Color swatches. I think that's the Okay, this one is the color swatch, it seems. Clear what color swatches. Ratatouille mascot is this one. Okay, so it is this one. Render create description. Okay, render create description is this one. About us. Okay, what's in here? Okay, so this is the swatch. Oh, destroy is here. Okay. Destroy mode activated by pressing D. Okay, pressing D, destroy. What does it do? Frame count. Saturating. Sub. And then there's a delay. Delay. Delay the start of the animation. Okay. I think we're on the right track. So delay. And then saturating sub. Frame count returns the current frame count, which is a sequence number indicating how many frames have been rendered, not including this one. Okay, so it can be used for purposes such as animation, performance tracking, or debugging. Each time a frame has been rendered, this count is incremented, providing a consistent way to reference the order and number of frames processed by the terminal. And the count reaches its maximum value, max, it wraps around to 0. This count is particularly useful when dealing with dynamic content or animations, where the state of the display changes over time. By tracking the frame count, developers can synchronize updates or changes to the content with the rendering process. Okay, frame count. Print line, current frame count, current count. Let's try this. But the problem is, how do we print this one? Okay, so maybe not print line. Maybe we can put it inside the status. Where's the status? The status is where? Okay, so this is the pop-up. Footer is here, status is here. Okay, maybe let's insert it here. What is the frame count? So self.filter status equals to current count. Let's try. This one. I think this one. No, this is JSON editor. Here. Could not compile. Oh, expected string found use size. Okay, thank you. Do something like this. String from current count was this word. Nope. Push. Okay. Push str. Push str. Current count. Huh? Not correct. How do we append to that one? Rust programming to string. Okay. Yeah, push str. But we are okay, so use size. Append use size to string. Use size to string. value to string. Okay, so just change it to string, to string. Okay, so footer. Okay, hopefully we can see some frame count appearing in the footer. What happened? Is it stuck? Oh, there. Why it's 0? Two, it becomes 2, 3. Oh, every time I press the frame is incremented. Okay. Quit. Quit. Okay. So every time I press, the frame count is incremented. Each time a frame has been rendered, this count is incremented. Saturating sub. Saturating the numeric bounds instead of overflowing. Delay. I think trip is the one animating the palette, the color palette. Frames. Oh, here. Fractional speed. Frame count divided by ramp frames. Variable speed. Fractional speed, fractional speed. Okay. What does it do? Ratio. Fractional speed, variable speed, pixel count. But how is the delay being used? Draw some text fading in and out from black to red and black. So the secret is here. Just need to figure it out. Ratatouille frame count. Here. Inside the closure, frame count is called to retrieve the current frame number. Let me think. So we have frame count. It seems like if there's a change in the UI, then it will increment the count. Change in the UI. If I don't do anything, frame count is 0. If I press Ctrl C, there it becomes 1. Becomes 1. So if I press Ctrl Q, it becomes 2. Now it's stuck. Ctrl Q. Becomes 23. Press tab, becomes 24. So if I press enter, say if we change something 5 times, then the frame count will increase. If we are at 25, behind the scenes, we change 5 frames, then we check after 5 frames, we'll put it into this kind of state. Maybe it will work, just maybe. Okay, I'm pressing tab. 34, 35, 36, 37, 39, 40. Okay, let's try something. But how do we reset the frame count? I think we can save the state. So just add something here. Frame, current frame, which is U size. Let's make it compatible. And then if I press enter, yes button press. What I will do is pop up and push self dot current frame equals to frame self dot frame frame dot count at the time when the button is pressed. That's the current frame. Let's try this. It's wrong. It's an error. Okay, so let's open up the quit pop-up, control Q, current frame is 0, tab still 0, then only when I press enter, still 0, it's 3, 4, okay, so every time I press enter here, changes 26, 29, 30, 31, 32, 33, 36. So somehow it was able to store the value. Don't call frame count here. only when we press the button that we call the frame count. Okay. Control Q. Tab, tab, tab. Control Q, tab, tab, tab. So that is 4. If I press enter, okay, so it's still 0. Press enter again. Why is it 5? Why is it 5 now? Press enter 0, and then the next time I press enter, it becomes 5. Why? Is it because of this? 1, 2, 3, 4, 5, 6. That is 6. So if it's 0, 0, 1, 2, 3, 4, 5. Zero, 1, 2, 3, 4, 5. Okay, let me try again. If I press enter, 6, 7, 8. Why was it 5? Okay, let me count the steps again. Control Q, that is 1. Tab, that is 2. Enter, that is 3. 3. So if I press enter again, okay, got it. Got it. Okay. So somehow we need to move the frame in such a way that we have I feel that there's still something missing. I know that we need certain frames to animate. So, for example, to get to this one, maybe 1, 2. We need to return it back to this state. So at least 1, 2. 1, 2. 2 steps. Unpressed, depressed, and unpressed. One, 2. Okay, so 1, 2. So at least 2 frames. 2 frames. We need 2 frames. How do we move the frame? It's a question now. Programmatically. How about if we do another approach? So if we do it time-based, like for example, at the time we press enter, where is it? Okay, at the time when we press enter, then we are recording the current time. Then we can have a condition that if the time is after 5 seconds, then we display this one. Or where's the pressed? Magenta, where's the magenta? No button pressed. Cyan, light red here. At the time when the button is pressed, we record the time. And then after 5 seconds or 2 seconds, then we will display this. And then after another 2 seconds, we will put it back. Maybe that will work. Maybe. Okay, so let's try that approach. Let's just keep it here. But how do we record the time? Do we record the time? Time duration. Okay. What do we have here? From seconds 5. Do we get? Oh, okay. Let now equals instant now. Instant now. To calculate how long a function took to run. Now that elapsed. Oh, okay, maybe we can use this. Elapsed time. Instant now. Okay. Instant now. Okay, instant now. We need to store this. So yes, time or yes, press time. It's the data type of that one. instant. Now equals this now is instant. Okay, so this one should be instant. Express time. Okay, so it is pressed. Okay, so it is pressed, and then if self that yes press time that elapsed elapsed um sex was to okay, then we display this one. This will work maybe. Shouldn't be equals, it should be okay, let's make it equal. Okay, so then maybe we record the time again here. We do it this way, this is complicated. Let's make it simple. Come back here, press time. What's wrong here? What's wrong? Instant is here. Do it like this also. will put in now. Does it work? Be just a number size. Then expected use size found instant. Trait bound instant default is not satisfied. It's not implemented. Default is not implemented. Instant. Do I even have to store it? Question. now was instant now. If now okay, if now elapsed a seconds too, so it will switch to red. Then probably here, remove that. Now elapsed seconds was to 4. 2 seconds, 2 seconds. Let me put it back. Will this work? It's about experimentation. Let's see. Okay, Control Q, Tab, Enter. Sad to say, nothing happened. Enter. Sleep duration, new. Okay, let's try this one. Sleep, quick fix, import sleep. Oh wait, Tokyo, time sleep. Okay, let's research on Tokyo later as well. This one doesn't work. C, Control Q, Tab, Enter. Oh, all right. So it worked. It worked, guys. It worked. So okay. And then there's something wrong with the putting it back. So excited. No, something is wrong. I cannot quit out there. it means I need to set it again, maybe. Now plus instant now, something like that. Right. Okay, Control Q and enter. That's longer than 2 seconds. That's more than 2 seconds, it seems. What happened now? Enter. At some point it worked. Let me comment this out. There's the parenthesis here. We comment this out, then run it again. At least we get to see the button is being pressed. Control Q, tab, enter. There. Okay. So at least the button press now we can see. So tomorrow stream again, then I'll work on getting the button to be depressed, put it back into this kind of state. Yeah, so I hope you guys can join me tomorrow and let's see how it goes. All right, I hope you also learned something today as well as I did, though the progress is slow. Yeah, so it's worth discovering new things. And thank you so much for joining me today. Before I finally end, let me thank my supporters. Thank you.